and I'm so excited to be back. I was out sick for a little bit, but I'm so happy to be here with you guys, helping you with your math homework. So if you are new here, welcome. And if you are a faithful viewer or you come back and need help from time to time, welcome back. So the way it works is this. So what you're going to do is if you need homework help, you can either call in this number that's on the screen, so 609-615-0606, and I will help you with your homework questions. And there is a Google form in the description of this video where you can submit your questions on that form. If you have a picture of it, that will help me, to better help you. But you can just call in and ask me your questions. So that's how it works. So at any point during the show, if you have a math homework question and you need help with anything, go ahead and call there. All right. So tonight we have a special guest. What we're going to do is the topic is surface area of 3D figures and volume of 3D figures. Okay. So 3D figures are like this, like this tissue box, okay? So this would be a 3D figure, right? There's 3 dimensions, okay? Or this water bottle is like a cylinder. This is a rectangular prism, and so on, okay? So let me bring in my guests. Let me make sure they're ready. Hello.
Hi.
How are you?
Good.
Okay, so let's do some volume and surface area. So which would you want to start with, volume or surface area?
Surface area is pretty simple.
Okay, so that's what I was going to suggest anyway, so that's perfect. All right, let me move you over to this screen, and then I'm going to share. Here we go. Okay, so surface area usually is the best one to start with because it is a little bit more complicated than volume, which is fine. Okay, it's complicated doesn't mean it's difficult. Okay, so rectangular prism. So just like this tissue box is a rectangular prism, do you know how many sides are in a rectangular prism?
6.
Yeah. Okay, so rectangular prism, we draw it like a cube, sort of, kind of. One thing about Miss Moore, I'm not the best artist, but I do try. Okay, so here is a rectangular prism, and done. Okay, so here's a rectangular prism. Oh, one more. Okay, so we have 6 sides. Okay, so we have a front and a back. We have a top and a bottom, and we have 2 sides. Do you know what surface area is? Like how we normally find the surface area? It's okay if you don't.
Yeah, I'm kind of on that.
No problem. So I'm gonna put 5 here. Let's say I'm making up these numbers. Let's hope they work out. They should be the same. Let's make this a 4. And no, hold on. Top and the bottom, back and the front. All right, let's leave that as a 6. Okay, so this is a rectangular prism. Surface area. Well, surface just means everything on the surface, right? So all of these sides, we're not worried about what's inside of this at all. It's everything that's on the outside. So surface area just means find the area of all of these sides. You're going to find the area of each of these 6 sides and then add them together. And that's surface area. You're adding all of the areas. So take the area of the front. Now, what do you know about the front and the back?
They're the same, right?
Yeah, they're going to be the same, which is great because if I find the area of the front, the area of the back is going to be the same. If I find the area of the top, what's going to be true about the bottom?
They're going to be the same.
Yep. And if I find the area of the side, the other side is going to be the same, which is good because I only have to find the area of 3 parts and then multiply by 2 because it's all the same. Okay. So let's start here. Let's start with the bottom rectangle. Okay. So you can see the rectangle on the bottom, right?
Yeah.
This is a rectangle. Okay. What is the area formula for a rectangle? So we're starting with a rectangle, and I'm going to write the word bottom. Okay. Do you know the area formula for a rectangle? So if it looked like this, how would you find the area of the rectangle?
Multiply by multiplying?
Yeah. So we're going to do length times width. Okay. So this is the bottom, right? We're taking the bottom. What is the length here, or the longest side?
6.
So good. And what's the width? So we have 6 is the length, and what's your width? What's this right here? Wait, can you see that? So what's your width?
5.
Yeah. Okay, good. So you just take that rectangle that's on the bottom here and you multiply together. So you have your length, or your longest side, and your width, which is 5. So 6 times 5 is what?
30.
30. Excellent. So that's the area of the bottom. Now, if I have the area of the bottom, what's my area for the top? Because you told me they're the same. So what's my area?
30.
Good. It's 30. All right. So 2 down, 4 more sides to go. Here we go. Now let's do the front. Actually, let's do the side. I think that'll be easier for you to see. So here's a side right here. What shape is that?
A rectangle?
Yeah. So we have another rectangle. It's the same formula. So rectangular prism is nice because it's the same thing the whole way through. Area equals length times width. So we have a 3 here and we have a 5. What are we going to do with both of these?
Multiply them.
Excellent. And 3 times 5 is?
15.
He's on fire. All right. So this is side 1. So this side, opposite it, should be what? So if this side in green is 15, the side right across it should also be what?
15.
15. Okay. So I have 2 sides that are 15. So let's pause. We have the bottom, we have the top, and now we have the 2 sides. Okay. Lastly, we're going to take the front. So let's do this one in the front. Got a lot of nice colors here. All right. So we know this side right here is how much?
6.
6. Perfect. Okay. So we have the front. Again, it's length times width. Our length is going to be 6. Now, what's my width? How tall is this right here?
1.
Not 1. It's the same as this. So
3.
3. Excellent. And 6 times 3 is?
Sorry, what was that?
6 times 3?
24.
Okay, 6 times 4 is 24. Go down 1. 6 times 3.
18.
Yes. Good. Okay, so if the front is 18, that means the back is
18.
excellent. Now, what am I going to do with these 6 areas? So we found the area of all the sides. Okay, remember surface area is adding all of the sides. Okay, now for this unit in your class, does your teacher allow calculators for this unit?
Yeah.
Okay, so go ahead and plug this into the calculator. So 30 plus 30. Okay, at this point with geometry, a lot of us teachers, you know, we've tested you on your number knowledge and multiplication. So at this point, we just want to make sure you understand the formula so you can use your calculator for this. So now plug these numbers into the calculator. 30 plus 30, make sure you have 6 numbers that you're adding together and tell me what you get. Hey, Josh, my faithful viewer. All right, tell me what you're getting.
126.
Say it again.
126.
Okay, yep. 126. Now, let's say this was inches, right? Do you know what the units are going to be?
No.
Okay, so with we'll come back to units, but it will be inches squared. Okay, but we'll come back to units. For now, I want to make sure you know the area of each side, how to get that, and then add them all together and find the surface area. So let's do it again. This first one is great. So the cool thing is the last time we were here, we had another student guest that wanted help with surface area. No, she wanted volume. So we had another student guest that needed help with volume. So now we're doing surface area. We'll do volume in a little bit, but we'll do surface area. We have another student guest backstage. I'm so excited. I'm so excited to help y'all. This makes my day. Y'all have no idea. Let's see. Let's pick some random numbers. Let's do 6. Okay. So tell me where I'm starting. So first things first, what is surface area? How would we find the surface area? So I want to see what you remember. How do we find the surface area?
We multiply the sides.
Okay, and then so what are we doing when we're multiplying the sides? We're finding the what? Because you're right. Do you remember that word? So when I take, let's say I have 2 and 3, and I multiply these together, 2 times 3. What's the, what do we call the 3? What do we call this side? Or the 2? Because we're using a formula. What's that formula? Do you remember?
Yeah, I'm trying to look at my notes.
That's okay. So it's just the area. You're absolutely right. We are multiplying it, but we're finding that. So the first step is to find the area of each side. So you're correct, because we do end up just multiplying the dimensions on each side together for all of the sides. So find the area of each side. And then what did we do when we had all 6 areas?
We multiply by 2.
Not 2. What did you do at the very end? What did you put into the calculator? What were you doing with all 6 of those numbers?
Adding them?
Yep. So you find the area of all the sides and add them together. That's it. So you find the area of all the sides and add them together. That's it. So what side do we want to start with? You want to do top or bottoms, the two sides, or do you want to do front and back? Which one?
Top and bottom.
Okay, let's do it. I like to start with those two. Okay, so here we go. And what shape is this? I didn't draw it pretty, but you know, what shape is this?
A rectangle.
Thank you. I know it looks like a parallelogram, but it's supposed to be a rectangle. Okay, so we have the bottom, and which is also the same as the top, right? So what I want you to start doing is organizing your paper, because as you saw, for surface area, there's so much to do. There's so much calculations that you have to do. So if you get used to organizing it, you won't leave out any numbers and you'll be able to do this no problem. Okay, so we have top and bottom, front and back. And what's the last thing? What did I miss?
The sides.
Yep. And then we have our two sides. Okay. So let's do it. So we know that once we have the bottom, the top is the same thing. Okay. So the bottom is a rectangle. What is the area of the rectangle? What's that formula?
$17.
Not yet. So area equals length times width. Okay. So your area is going to be the length times the width. So here is in the pink, right? I'm just pulling this rectangle over here. So this is your bottom. So my area is my length times my width. So what am I multiplying? What two numbers am I multiplying?
7 and 6.
Good. Okay. So what is 7 times 6?
42.
Excellent. And because there's a top and the bottom, what am I going to do with these?
Add them.
You can add them or you can multiply by 2. It's the same. So we can just write it twice, right? This is the bottom and this is the top. Okay. So we have two areas so far. So far, so good. Now, so you were saying we can add them together to find the total for the top and the bottom. You absolutely can. All right. Now let's do the front and the back. Let me use green. All right. So here it is. Oop. So we have this front part right here. Got another rectangle. And what's my length? Have a good night, Josh. Thanks for tuning in.
7.
7. Excellent. So we have length times width. We have 7. And then what's this right here? How much is that?
Your mouse isn't moving.
Oh, sorry. Let me put a arrow. How much is that?
7.
So that's
4.
There you go. Good. And now 7 times 4.
32.
8 times 4 is 32. So 7 times 4.
28.
Good. All right. So now we have the area of the front, and the area of the back is also going to be
7.
So if the front is 28, the back is going to be
28.
Good. So this is the front, the back is 28, and add them together.
56.
Good. Okay. And then finally, we have the sides right here. So what's this rectangle? right here that I just colored in. So what's my length and what's my width?
4 and 6.
Good. Okay. So 6 times 4. So 7 times 4 is 28. 6 times 4 is
24.
excellent. And if my one side is 24, the other side is
24.
yes. And now add them together. 24 plus 24 is
48.
48. Okay, what am I going to do with all three of these?
Add them.
Yes. So in your calculator, go ahead, put them in. 84 plus 56 plus 48 and tell me what you get.
A 188.
100 and say it again.
88.
Okay. That is correct. Awesome. 188. So I want you to notice that we're finding the area of all the sides and then adding them together. Okay. Now, you may have seen for the area of a surface area for a rectangular prism, does your teacher teach something like, well, where'd that go? Okay. This formula. Does your teacher do that where you do 2 times the length times the width times the height, and the length times the height? Have you seen that?
No.
Okay, good. All right. So don't worry about that. I just want to make sure that if your teacher did show you that way, that I'll explain why it worked, but it's fine. So again, surface area, you're finding the area of each side, and then you are adding them together. Okay? So find the area of each side and add them together. So I'm going to give you a problem. I'm going to bring on my next guest, and then I'm going to bring you back, okay? So I'm going to give you this problem right here for a rectangular prism. Okay, remember you are finding the area of each side and then adding them all together. So I want you to take it one at a time. Well, this will be 10. Oops. This will be 5 and 2. Okay, so write that down in your notebook, and we will be right back. Okay, let me remove you. All right, so great job. If you are tuning in and you have a homework question, make sure that you call this number, 609-614-0606, and you can ask me your homework question. I'm going to bring my next guest on very soon. My first guest, just let me know if you have this copy down.
Yeah, I do.
Okay, perfect. All right, let me remove my screen. Perfect. Okay. Hello, guest number 2. How are you doing? Uh-oh, are you here? Let me send him. Oh no, it's not connected. Okay. They need to connect their camera. Okay, hopefully she'll come back. But that's all right. So I'll bring you back on, guest number 1. And when she comes back in, I'll let you know.
Okay.
Okay. So let me know what you're getting when you finally have it. Okay. So let me know what you're getting. So tell me what, oh wait, I think our guest number 2 is back. So hold on, let me try it again. Okay, keep working on that one. Let me try guest number 2. Hello, welcome. Can you hear me? Okay, I want to keep you anonymous, so I'm not going to say your name. I'll just say T. So T, can you hear me? Because we can't hear you. I want to make sure I get to your question. Okay, you can hear me. Sorry, I just missed your chat. Okay, good. Okay, here we go. Yay. Okay, there you go. Okay, so can you unmute your mic or just say something so everybody can hear you? Okay, so your question last week, I'm pulling it up now. Okay, here we go. So, oh no, I think she got disconnected again. Well, I'm going to read the question and maybe she'll be able to come back. Oh, there she is. Okay. Girl. All right, so here we go. Sue is planning a shopping trip to get holiday gifts for her friends and family. She decides to get each person a $20 restaurant gift card. She also wants to pick up some toys for her dog, which will cost $17 in all. Which function could model this situation? So first things first, did they give you was it like a multiple choice question? Or they just wanted you to write the function? Let me know that. Because I can do both. I just want to make sure I'm giving you the right thing. Okay. I'll wait for you to say that. Okay, you don't remember. Okay, so for those who are watching, she's just typing to me in the chat. So I'll just read what she types. Okay, so let me add this to the stream. Okay, so it says Sue is planning a shopping trip. So first things first, do we know? Tell me what we do know. Okay, so when you look at this, what do you know for sure? Because a lot of times we see all of these words and it's just like crazy, right? So we know that her name is Sue, right? She's planning a shopping trip. She's getting gifts for her family. And we need to know, so it says each person, she's going to get each person a $20 gift card. Okay, that's important. Okay, she's going to pick up some more toys, and all of those toys are going to cost $17. Which function can model this situation? Now, they use the word function. It's the same as saying what equation can model this situation, because they're saying, well, I know the toys are going to cost $17, but do I know how much the gift card is going to cost? So if you're looking at this and she's giving each person a gift card, do we know the total cost of the gift cards? Like the graph, I do believe. Okay. So let me know, are you having an issue with your mic? Because it just will help me help you a little better if you could talk. Okay. You're having issues with your mic. Okay. No problem. All right. So $17 in all. They gave you. Okay. We're having some connection issues, but that's okay. So you're saying they gave you a graph. That works. All right. So in order to know what graph is going to go there, you have to know the equation first. So you need to know the equation first so that you can identify which graph is going to work. Okay. So if we were to write an equation for this, so
Hello?
oh yay, there you are.
Okay, cool.
Yay. Perfect. Okay. So they gave you a like multiple choice with graphs.
I think so. They did. I did this a while ago.
Okay.
It's on this program called iExcel.
Gotcha. I've done Excel. Okay.
Yeah,
I used to work for them.
No.
I know. Everybody hates Excel, but I did work for them for a little bit.
I was working on the function transformation checkpoint, and
Mhm.
I'm on a different question now. Can we work on that one?
Oh, sure. Yes. I'm sorry. I was trying
Okay.
to do the. All
We
right. Go ahead.
can-
What question?
I'll put it in the chat real quick. Hold on.
Okay. Even better. Okay. What must be done to the graph? Okay. So I'm going to assume I'm going to copy it here, but I'm also going to write it because okay. I'm going to assume those are like x squared.
It's called. It's asking for the stretch the graph horizontally or vertically, like to stretch it or to shrink it.
Gotcha. Is that a 1 or 12?
It's a 1/2.
Oh, 1/2. Okay.
Yeah.
All right. So what has to be done to this graph to get to this? So first things first, just look at it. What's the difference between this equation? Let me circle it. What's the difference between 2x plus 1 and x squared plus 1/2?
Well, one of them has 2 in the first section, and one
Good.
of them is a 1/2, while the other one is just a 1.
Okay. So to get now, even though I can't see it, what's in front of this x? Even though I can't see it.
A 2?
Not a 2, because then it would become 2x squared, right? I can put something here that doesn't change it from being x squared.
A 0?
Okay, so if I do 0 times x squared, 0 times anything is what?
0.
Right, so it stops being x squared. I need to put something here that will keep it as x squared. What can I multiply by x squared that equals x squared? So 5 times what equals 5? 6
10.
times what equals 6?
12.
7 times what equals 7? What number when I multiply?
X times x over 2?
Not x over 2. So just look at the numbers. So let's just work with numbers, right? So
Okay.
5 times what always gives you 5?
1. Oh, 1.
There we go. Okay. So when you're doing algebra, right, there's always this invisible 1. We never write 1x because it just means 1 times x, which is x, right? Mm-hmm. So even though this is going to help you, right? So to go from 2x squared to 1x squared, you did something. To go from 1 to 1/2, you did something to this. What do you think we did to this? To get rid of that 2 and get 1, and to get rid of this 1 and get a half.
You went down.
Okay, but what else? How did I go down? Think about an operation. What operation did I do? Right? So could I have added to get to 1? Could I have taken this 2 and added to get to 1?
Could have subtracted to get to 1.
Okay, so let's see. Now, whatever I do to this 2x squared, I have to do to the 1, right? So if I subtract by 1 over here, did I subtract by 1? Is 1 minus 1 1/2?
No.
No. So that I couldn't have done. Okay. So I didn't add. I didn't subtract. What about multiplying?
You might divide.
Okay. What would you divide by?
Maybe like, I think maybe 2.
Okay. Let's try it. What's 2 divided by 2?
4.
No, divide it.
No. Oh, 2.
So
wait, no.
2,
It's 1.
yeah, you got it. Okay.
Okay.
So far so good. Check. What's 1 divided by 2?
2.
No, 2 divided by 1 is 2, but 1 divided by 2, if I take 1 and I split it in half, it's just what?
1.5.
1/2. Is that what we have right here?
Yeah.
Yeah. So you're absolutely correct. We divided it by 2. So first things first, you said we shrunk it, right? We made it smaller
Yeah.
by cutting it in half.
Okay.
We divided it by 2. So what were the answer choices? Was it just shrink it?
It was shrink the graph horizontally, shrink it vertically. I think.
Okay.
What? Yeah, shrink it horizontally, shrink it vertically, stretch it horizontally, or stretch it vertically.
Gotcha. Okay. So we definitely shrunk it, right? It went smaller.
Yeah.
Okay. So now what's the difference between horizontal and vertical?
I think
So how do we know when we're shrinking it horizontally or not?
Isn't horizontal like up and down?
No, it's left to right. So horizontal is left to right.
Okay. Oh, so it would be shrinking it vertically then, because we went up and down.
Okay. Did they give you a picture of the graph at all?
No.
Okay, that's fine. All right. So let me just get this for you because I want to make sure I'm giving you the right thing. Okay, horizontal stretch, vertical stretch, when b is greater than 1 and when, okay. There we go. You're definitely shrinking it. I just want to make sure you're going vertically or horizontally. See it here. Okay, so k times is greater. It's being stretched. If it's a fraction, it is. Okay, it's vertically. You're right. Okay, so when we divide, so here it is, y equals, so when you have a function like this, y equals k times f of x, okay. So this k, so you either have y equals k times f of x or y equals f times kx. I think actually, I'm sorry. this is vertically. We didn't do anything. So vertical, shrinking, and stretching. So this is the formula for that. Horizontal is this. That's when we change something about the X. So horizontal, if we were to change something about the X itself, that's when it would be horizontal. But here, we just took this whole function and we divided it by 2. So when we change the whole function, like right here, that's when it's vertical. So when K is greater than 1, like if we had multiplied this by 2 or something, then it would have been stretching. But since we cut it in half or multiplied it by 1/2, since K was a fraction in between 0 and 1, that's why it shrunk vertically. Okay, so I just want to make sure I explain that to you so you make sure you get it right with the vertical and horizontal. Okay, so because we took that whole function and we cut it in half, we didn't just focus on the X by itself. We took this whole thing and we divided it by 2. Okay, so we knew it shrunk, but we had to just make sure that did it go up and down or did it go left to right? And it was up and down because we did it with the whole thing. Okay, but did that help you to see that we divided it all by 2?
Yeah.
Okay, do you have another problem that's like that?
I have one that has a chart this time.
Okay, so do me a favor, in the description on YouTube, there's it's the same form you used before. Mm-hmm. If you could take a picture of that and add it to the form, that will help me out a lot. Okay. Okay, so I'm gonna remove you while you do that, and I'm gonna bring up our first guest. Okay, so how did it go? Where did I move the problem? Did I get rid of it? Oh no. Okay, so tell me what you got for it. I think I used 10, 5, and 3, right?
10, 5, and 2.
Oh, 10, 5, and 2. Thank you. Okay, so what was your surface area?
160.
Okay, so tell me what did you organize it where you put bottom and top?
Yeah.
Okay, so what was your area for the bottom?
For just the bottom and top?
Yeah.
50.
Yeah, good. Okay, so your bottom was 50. That means your top was
50.
Good. Okay, and now what did you get for your sides?
Oh, sorry, I was muted. I got 10.
Good. Okay, 2 times 5. You're on fire. Yes. Okay, and now what did you get for the front and the back? So
20.
Good. 2 times 10. Excellent. Okay, and then you added them all together. And tell me what you got again.
160.
Yep, that's good. Awesome. So what helped you do this?
Looking at the notes and the organization.
Okay, cool. All right. So now, how do you feel about rectangular prisms? You feel more comfortable with that?
Yeah.
Okay. So we can do triangular prisms or cylinder. Which one?
Triangular.
Okay. So triangular prisms. So just like a rectangular prism, the reason why they call it a prism is that all of the sides are rectangles. Okay. So all of the sides are rectangle. The only thing that changes is the base. Now, the base here, unlike the rectangular prism, the triangular prism has triangle sides. Okay. but everything else is a rectangle. Okay, so we have triangle sides, but if you look at what's on the bottom, what shape is this on the bottom?
A rectangle.
Yep. And then if you look at the side, what shape is this on the right side? Oh, sorry.
A rectangle.
Yep. And then on the left side is a rectangle as well. Okay. So I just wanted to make sure you saw that we have 2 triangles and 3 rectangles here. So we have 5 sides. Okay. So 2 triangles, 3 rectangles. Now, same thing. We're finding the area of all the sides. The only thing that changes, so this, let's say this is a 3. This line right here that I drew in is a 2. And this is going to be that's going to be 8. And let's say right here is 4. Okay. So first things first, we're going to find the area of the 2 triangles. Then we're going to find rectangle 1, rectangle 2, and rectangle 3. Okay, because sometimes the rectangles will all be equal and sometimes they won't. But what will be equal are the 2 bases, the triangles. Okay. Do you know the formula to find the area of a triangle?
I think it's in my book.
Okay. So here's something I do with my students, right? A lot of times they'll do a parallelogram or a rectangle. It's base times height. So a triangle is just half of that. Okay, so a triangle, you take the formula for a parallelogram, base times height, and you just divide it by 2. Okay, so for a triangle, it's base times height divided by 2. A triangle is half. So if the whole rectangle is base times height, you just cut it in half and that's your triangle. Okay, so base means bottom. What's the bottom of this triangle? What's the bottom right here?
A rectangle?
No, what's the length of the bottom?
Oh, 3.
Yep. Okay, what's the height of this triangle?
2.
Yep. And 3 times 2 is?
6.
And 6 divided by 2 is?
3.
3. And now I have 2 triangles. So this is the first triangle. And the second triangle is what? So if the first triangle is 3, the second triangle is also
3.
3. Okay. And so we have the area of the 2 triangles. 3 plus 3 is?
6.
6. Okay. So that's the area of the 2 triangles. Great. I'm done with triangles. We like rectangles. It's very easy. You can say base times height or length times width. And it's the same for all of these, right? Same formula, I should say. Okay, let's start with the bottom. So this bottom part right here. What's my length and what's my width? So how much is this right here?
8.
Yep. And then what's my width?
3.
Yep. And 8 times 3?
24.
Good. Okay, so we just took care of the bottom. Okay, that was this part right here. That was the bottom. Now, let's take care of that left side. Okay, so how much is this right here?
8.
So, yes, 8. Good. So that's 8. And what about this side right here?
8.
Well, this is
two.
right here.
Two.
Well, no. So I know it's confusing, but the 2 went toward that. They drew in the height. So if we have a triangle, this dotted line that I drew in, that's the height. So that doesn't represent the sides. The sides are 4. Okay, so the 2 sides are 4. I should have labeled that. Okay, so now what's this? Let me do pink.
4.
Good. All right, so we have 8 and 4. And 8 times 4 is?
32.
Good. Okay, and then the last one. Now, I know it's hard to see, but I'm going to just draw it this way. Oops. Okay. So this rectangle right here. Okay. What's my length?
8.
Good. And my width?
4.
Good. 8 times 4?
32.
Good. Now add them all together. Okay, so we have 6, 24, 32, and 32. Tell me what you get.
$94.
Okay, so that's 68 plus 30. You said 94?
Yeah.
Not 94. Oh, I'm sorry. Yes, I'm adding wrong. Just checking. You were right. Okay, so surface area is 94. Okay, awesome. Good. So that was great. I'm going to give you another one right now. Okay, so try this one, surface area of a triangular prism. So you're going to find the surface area. So find the area of the 2 triangles and then find the area of the 3 rectangle sides. Okay. Do you have any questions for me about this? Are you understanding it?
Yeah, I'm understanding it.
Okay. So these 2 sides are going to be 4. No, we did 4 already. Let's do 2 and 2. Okay. So this side right here is 2, and the other side also is 2. Okay. We're going to draw in the height because the height has to form a right angle with the base. Okay. This height, I'm going to put, let me use a different color. Okay. This height is 4. Okay. Down here is 6. This base is 6. And the last thing, we will use 11. Okay. So copy this down. I'm going to go back to our student guess number 2. Okay, let me pull up the question. Okay, there you are. Okay. So let me pull up this graph. Guess number 1, have you copied this down?
Yeah.
Okay, perfect. All right, you work on that. When you have it, just in the chat, tell me that you have the answer, or you can put your answer in the chat too. Okay. Hello. So let's get this picture up on my screen. Let me see how I can do that. Okay, I can download it, and then let's see if I can add this image. Okay, we can add it. I just need to rotate it a bit. Okay, here we go. So it says the graph of fx and f of g of x appear below. You're going to, how can g of x be expressed as a transformation of f of x? So what did we do to move it up or down? So what happened to g?
G got moved.
So so tell me from f of x to g, what did you do?
Huh?
So here's the.
Are you talking about if I'm supposed to go up or down?
Right. Yes, that's what I'm talking about.
Okay. You would go express the transformation of x. So you would go down.
So to go from red to green, what did you do?
I was supposed to go up.
Okay.
So you're supposed to add. But
so they're saying g of x, you took this and you went up 2, right?
okay.
Do you see that?
Yeah.
Okay. So, and then I can just, hold on. Let's use a highlighter. Okay, so we were here and then we went 1, 2. All right. And all of it looks like that, right? We were here, we went up 1, 2, all of it. Okay. So how do we increase vertically? So we know we're adding 2. Now the question is, which one is going up? Is it, oops, sorry. Let me zoom in. Okay. So is it, so we can cross this off because we went up 2. So which
it
one
could,
is it? This one, let's call it 1 or 2. Which one? Let me get there. So
2.
Okay, now I want you to sound sure of it. So why is it 2?
2 because it's going vertically, right? Because when you do f with f of x and then the 2 by itself, that's going up and not going side to side, right?
Good. Okay. So when you just add 2, you're shifting it up vertically. But if you were to change something about the x, so we talked about that before, right? If we were to change something about the x, that x plus 2 would mean we were going to the right 2. But this just takes f of x and makes it go up 2. Okay?
Okay. Oh, okay.
Okay, so think of it like this, right? I have this graph, and all I'm doing with this graph is moving it up.
Right.
Okay, that's all we did here. So let's say we have x is 0 here, right?
Okay.
So x is 0 and f of x is -1, right?
Okay.
Okay, so if I take this f of x and add 2 to it, -1 plus 2 is what?
1.
1. So my new mark is 1, right? So now g of 0 is 1. That's what we did. Now, if you were to do the other thing, right? If you were to go right, let's try it. So if x is 0 again, okay. So if x is 0 and we say f of 0 is -1, change this x. So now I want to make it I want to make g of 0 the same as 0 plus 2. So what's 0 plus 2?
0.
Well, 0 times 2 is 0, but what's 0 plus 2?
2.
2, okay? Now, what's f of 2? So if I was looking at f of 2, okay, here we are. I go up here. So when x is 2, what's y?
Okay, if x is 2, y would be... Wouldn't it would be either 0 or 2, right? No.
So,
whoa.
Hold on. Let me show you. So here's x, right?
Okay.
You see it?
Yeah.
So x is 2. Let's go up to the graph until we get to that red line, right? So we have 1, 2. Are we at the red line?
Yeah.
Okay. So look at that y value. What is it?
3.
Yep. So f of 2 is 3. So they're saying that now g of 0 is now 3. So let me just show you what that looks like. So now, if we were to change this right here and add 2 on the inside, instead of having it here, we move it to x is 0 and we have f of 2, 2, 3. Wait, I did that wrong. So f of 2, no, that's right. G of 0 equals f of 2. And f of 2 is 3. So 0, 3. So it's 0, 3.
0 plus 3 is 3. Yeah, 0 plus 3 is 3.
I'm sorry. That's not right. It's negative 1, 3. F of 0. Somehow I did that wrong, but it's supposed to be this. It's supposed to look like that, but hold on. I don't want to confuse you though. But either way, you knew that it was supposed to be 2. I'll come back to this one.
Okay.
But let me not confuse you any further. First things first. You understand that it's 2, right?
Yeah.
What we did. Okay, good. So let me stop while I'm ahead. But g of x is supposed to be, so if it's like g of 0, it's supposed to be, if we were doing horizontally, it's supposed to be the same as 2. Okay, so technically. So something I did wrong. I think it's supposed to be like that. But yeah, don't worry about that. I did something wrong there, but you're fine. Okay. Was there another question you had similar, or were those the only 2?
I do have one more, but
with?
I do have one more.
Okay, go ahead.
That would be it. I'll send a picture. You can go to the other guy.
Okay. Sounds good. Okay, so what was the answer? Tell me. And there it is.
I got 144.
Okay, so tell me the area of the triangles.
$22. Oh, wait.
So let me see. Triangle.
12.
Yes, good job. Okay, so we had 6 times 4, which is 24, and then we divided it by 2, so it's 12. We have 2 of these triangles, so altogether you should have had 24. Now give me one of the rectangles. So give me the area of one of the rectangles.
6.
Okay, so rectangle 1. Tell me how you got 6. Which rectangle did you do? The bottom or the 2 sides?
The 2 sides. The bottom.
Okay, so what was your area for the bottom?
12. It was kind of hard. I couldn't
It was hard to see.
Wow.
Okay, so let me highlight it. Hold on. Okay. Okay, go ahead. So what's my length and my width here?
11 and 6.
Yep, there you go. Okay, so we have 6 and 11, and 6 times 11 is
66.
awesome. Okay, so now my rectangle number 2. What do we get? Give me the area of another rectangle you had. So let's try
22.
Say it again.
22.
Good. Okay, so this one was 22. Perfect. And that last rectangle in the back here, we have a 2.
22.
Yep, it's the same. Okay, because we're dealing with the same dimensions, 11 and 2. Good. So now you added them together, and what did you get?
144.
Say it again.
44.
Almost. So I'm getting 134, but let's just double check. Okay, so you did 22 plus 22 plus 66 and 24, correct?
And I didn't get a 24. I got a 12.
Yeah, but there's 2. That might be why. There's 2 triangles.
Oh.
So remember, we find the area of all the sides. So here's the first triangle, and then here's the second triangle. So there's 2 triangles. So you have to account for those 2 triangles. You have to find the area of both of those triangles. So the first one was 12, and the other one is 12. So 12 plus 12 is?
24.
Yep. And so when you add it in, that's what you should get. So you were close. You just had 1 triangle instead of 2. Okay. Is that helping?
Yeah.
Okay. Now, so you're doing great. So tell me again, how do I find the surface area of a figure? What are we basically doing to find surface area?
You're finding the area of each side.
And then what are you doing at the end with all those areas?
Adding them all together.
Yes! Woo! You got it. So yeah, you're finding the area of all the sides, and then you're adding them together. That's it. Okay. I probably should do pyramid first, actually. Yeah, let me do pyramid first for you. Okay. For a pyramid, do you know what makes a pyramid different?
It has, I can't really name it.
So think about the pyramids in Egypt. What are the shapes of the sides of a pyramid?
Triangles.
Yes. Okay. And the sides of a prism were what? So they weren't triangles. Majority of the sides, we always had, for the triangular prism, we had 3 what? Around the sides. What was it? So what shape, I should say. What shape was it?
Rectangles?
Yep. So prisms have rectangle sides, right? Or we say faces, right? So prism, these faces change, right? It could be a triangle. These 2 could be a triangle, could be a square, could be a rectangle, anything. But the main parts of it all around are rectangles, okay? Same thing with a triangular prism, a square prism, all that kind of stuff. So now, with a pyramid though, a pyramid has triangles. A pyramid has triangles as the, what do you call that? Pyramid has triangles as the sides, okay? The only thing that changes about a pyramid is this right down here. The bottom of it. Okay, sometimes it's a square, sometimes it's a rectangle. That's the only thing that changes. So if all of the sides that surround this square are triangles, let me make a better square. How many triangles are there? So there's a triangle on the top, bottom, side, and side. How many triangles are there?
4.
Yep. Okay. And if you have a pyramid and you were to open it up, okay, this is how it would look. Oops. Okay. This is how it would look. Triangle here, triangle here. I was trying to make a star. Triangle, 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 and triangle. Okay, that's how it would look. So once again, you're finding the area of every side. You're finding the area of the 4 triangles and then whatever shape is in the center. Sometimes that shape is a triangle in the center. And if there was a triangle in the center, how many triangles would surround this triangle?
4.
So there's one triangle in the center. So how many surround it? So this is the center one, sorry. So how many triangles surround that?
3.
3. Okay. So if I had a triangle as the bottom of my pyramid and I open that pyramid up, that's what it would look like. Okay. So the only thing that changes about a pyramid is that bottom piece. Okay. Sometimes it's a rectangle. Okay. Rectangle has 4 sides. So there will be 4 triangles surrounding it. Okay. Now the good thing is, you know your triangle formula, because that's going to really help you here. Okay. Because you know your triangle formula, this is going to be very easy for you. Okay. Actually, let me put that back. Okay, let's start with the bottom. Now they're showing you these tick marks because they're saying that all of these sides are equal. They're showing you that this is a square. So if I know that this side right here is 5, that means all of the sides of the square are what?
5.
Yep. Okay, so what's the area of a square?
20.
So if it's 5, right? What's 5 times 5?
I mean 25.
Yes, good. Okay. So that's good. You knew exactly what to do, right? So we have our square and it's 5 times 5, which is 25. Awesome. Now, let's handle these triangles is what I'm trying to say. Let's handle the triangles. And all the triangles are going to be the same. Okay. So what is my height? Look at this red line. That's my height. So what number is that?
8.
Yep. Okay. So we have our triangle formula, base times height divided by 2. Okay. What's my base of the triangle?
5.
Mm-hmm. So now I want you to do 8 times 5 and then divide it by 2. Tell me what you get.
$20.
Good. Okay. Now, if this is 20 and all of these triangles are equal, what's this? What's this triangle?
20.
Yeah, they're equal, right? That means this is 20, and that means this is 20. All of these 4 triangles are equal, and 20 times 4 is
80.
good. So I have the area of all 4 triangles. I have the area of the square. What am I going to do now for the surface area?
Adam?
Yes, you got it. Okay, now tell me what you get.
105.
Good. Wait, say it again.
5.
Yes, okay. I thought you said 105, and then I was like, wait, did he say 110? Okay, yes. So 105, and for area is always measured in squared. Okay, so it's 105 square centimeters. When you start working with volume, it's cubed. Okay, I guess a good way to remember it is the S for surface area is squared. S and squared surface area. No, squared. And then volume, I don't know how you'll remember it's 3, but it is. Okay, but how are you feeling so far about surface area? Do you feel like you're understanding it better than you did before we began?
Yeah.
Okay, so what part was confusing for you before we started?
The formula.
The formula, so just getting the formula down and understanding that, like, did it help to understand that surface area was just like finding the areas of all the side and adding it together?
Yeah.
Okay, cool. So I'm going to give you another pyramid question. Again, like before, just message when you have it, okay? So you're just taking the area, and the pyramid has what kind of sides? What shape?
Triangles.
Yep, good. Okay, so I want you to take this, and again, it has a square base. We can see that all the sides of that square is 16. The height of the triangle is 17. How many triangle sides do we have?
3.
So I have a square in the center, right? So I have this square right here.
4.
Good. Okay, because there's going to be a triangle on each side. Good. So go ahead and do it. I'm going to pull in guest 2 again. Okay. Hello. Okay, let me pull your question up. Okay. So let me download that and then bring it over here. And then turn it. There we go. Function and transformations. Whoo, girl. All right. So what is the hardest part for you with these? Like what do you feel like you struggle with the most when it comes to these?
Like how am I supposed to change it into a different form?
Okay, so how to go from like f of x to g of x?
Yeah.
Or tell me what you mean.
Because I get confused when it says write your answer in the form of like the formula down there.
Oh, I see. Yeah, I know. It gets confusing because they switch it up on you a lot, right?
Mm-hmm.
Okay. So where A, H, and K are simplified or fractions. Okay. Now, with the other ones, do you have a better understanding of the other ones before we do this one?
Yeah, I do.
Okay. So all of those made sense, right?
Yes.
Let me just check in with guest number 1 real quick. Did you get a chance to copy down the question?
Yeah.
Okay. I just want to make sure before I move it. Okay. Cool. You guys are doing awesome tonight. Okay. So Girl, you stretching me tonight because you know Miss Moore is a middle school math teacher, but I love it. You remind me of all this stuff. I love it. Okay, so f of x equals x squared. Now we need to know what g of x is. Okay, so let's pick out some points. So I see 0, -6. I see, let's see what else.
-2.
-2, -2.
+3.
+3 and what else?
I think that's it.
Yeah, I see ya. Okay, so it looks like it's the same number, right? We're getting 2, 2, 3, 3, -2, -2. The only difference for some reason is that 0, -6. And then we have 3, 3. Let's see what else. Does it stay that way? And then it goes to -410 and 410. So it actually jumps a lot. Okay, so -410 and 410. So we got to figure out, well, what is it doing? Oh, I wrote that wrong. I'm sorry. This right here is 2, -2. And then this was 3, 3, negative. Okay, the rest of it was good. -3, -3.
How is it 4 if it doesn't line up with 4?
What you mean?
With the -4, it doesn't, like with the -2, it doesn't look the same as -4. Like I would get -5, but not -4.
Oh, I think, okay, you're talking about down here?
Yeah.
Yeah. So it's -1. Let me write this in a better way. Let's organize this. Okay, so let's take, so my x and then f of x. Okay, so we have, let's start with -3, -2, -1, 0, 1, 2, and 3. Okay, so -3 is 3. -2 is -2. 1 is -5. We got 6, 0. Then we have 1, 5, -5. And then we have 3, 3, 2, nope, 2, -2, sorry. So now it's just going backwards with the same. Okay. So if we were doing x squared, so what can help you is just to try to plot it yourself. So if we have 0, what's 0 squared?
0.
Yep. Okay. What's 1 squared?
1.
Okay. And we would get like, 2 squared, 3 squared, and so on, right? So we got to graph it so we know what's happening here. -1 squared, -2 squared, and -3 squared. So it's going to help you a lot if you graph it yourself. Okay, so f of x was x squared. Okay, I'm not graphing this the neatest, but you get the point. Okay, so what happened to it?
It increased.
So this was f of x, right?
Yeah.
To go from f of x to g of x, did we move right or left, up or down?
Up and down.
Good. Okay, so we moved up and down. How many? So let's start at the 0 and let's go down. 1, 2, 3, 4, 5, 6. So we moved down how much?
6.
6. Okay, so we moved down 6 spaces. Let's check it again with this 9. Let me use, can you see that? Let's see. Okay, so we have 1, 2, 3, 4, 5, 6 again, and we land here. Okay, so you want to just take a couple points just to make sure that that's what we did, and we can see that's what we did. We moved down 6 spaces. Okay, so did we do anything to the X? Did we move it left or right?
No.
No. Okay, we left it alone, and now, so we didn't do anything with, so H means like we moved it left or right. Okay, we didn't do anything with that. But K, we did move it down, right?
Mm-hmm.
So we're going to take this, and it should be like this. Okay, because we didn't do anything to this X. And let me get that form for you. So it says A minus A form. Yeah, and we didn't have any, like if we had a 2x here, if it was 2x squared, then I would say A would equal 2, okay? Mm-hmm. But because we didn't have a 2 here, A is just 1, so we don't need anything right here for that A. So when they say write in this form, there's nothing here for A. It's just a 1. Because so A, it just means what can you factor out? Okay, so let me show you this. So if you have 2x plus 4, what number can you factor out?
The 4.
Well, by factor out, we mean what number can be divided into both of these?
2.
2, right? So when they say A, they're just saying what number can be divided into both of these. That would represent A.
Oh.
Okay. Now, if we did change something with the X, then yes, that would be H. Okay. Mm-hmm. But we didn't do anything with that. And then all we did was go up and down. So you know that part. Okay. And let's see. Oh, H is negative B over 2A. So B is 6. Let's see. Yeah, you didn't have a B in this example. So yeah, there's no H here. So you were getting confused by the form, right? Mm-hmm. Okay, so let me give that to you. There we go. So when you have an equation, it's ax squared plus bx plus c. So if this was like 3x squared plus 6x plus 3, right? I just made that up. Okay, so A is this number right here. Okay. H is negative B over 2A. So this is B and this is A. So A is 3. So we would do 2 times 3. And B, let me do a different color. B is 6. Now, in your example, we didn't have any B's, right? There was nothing attached here. Mm-hmm. There was nothing. So we didn't have to do anything. Okay. And then, so 2 times 3, and then B is 6. So it'll be a negative 6. This will be negative 6 divided by 6, which is negative 1. So in this example for you, they made it super easy just because there was you didn't have to worry about a H there. Now C is the same thing as K. Okay. C is it's actually K. Okay. So here it is. That's right there. Okay. And for you, because we moved it over, that's why we ended up having to add, what was it? Sorry. We moved it down. Sorry. So your K is like where you moved it. So K is at minus 6. Okay. And that's it. All right. You see it?
Mm-hmm.
All righty. So did you type in that answer?
Yes.
All righty. And what'd they say?
It's good.
Good job. But I think the easiest thing for you, to, even if you don't understand like what the form is, did it help to draw in the graph?
Yeah.
Yeah, because once you draw in the graph, then you'll be able to see, okay, we just went down. If you go down, it's going to be either, if you go down, it's a minus for the K, and if you go up, it's a plus. If you went left and right, for that H, you would just put in, let's say you went to the right 6, you would just do X minus 6. If you went to the left, X plus 6, and so on. Okay?
Okay.
But that's all they mean. So H, think horizontal. K is up and down. Okay. Okay. Any other ones, or that was the only one?
I do have a quick one.
Okay.
This one is h of x equals negative 5x 2 squared plus 8, and it's like, what's the rate of change of negative 30?
Okay. F, say it again. H of x equals negative 5x.
Squared. 2 squared plus 8.
Like that?
Yeah.
Okay. So negative 5x squared plus 8.
And then it was like, find the average rate of change t equal to negative 30.
Okay. So to make this equal negative 30?
Yes.
Okay, so let's see if that's what they want. Okay. So it looks like they just want you to solve it. So tell me this. How would you solve this?
So it'd be negative 10 plus 8, right?
Negative,
because you're no, it would be negative 25 plus 8, because you're multiplying the 5.
Wait, is it in parentheses like this?
No.
Okay, so if it's not in parentheses, the only thing that gets squared is the x.
Oh, okay.
Okay, so the first thing you have to do is take this plus 8 and get rid of it. How do I move this plus 8 to the other side?
You add it to the other side?
Okay, so if I add 8 to the other side, I end up with a 16 over here. Am I getting rid of that number?
Yes.
No, because I'm still left with 16 on this side. I want to get rid of everything on the right side except for negative 5x squared. Okay. So what can I do to the 8? So it's not adding it. You're on the right track.
Multiplying?
So again, what's the opposite of addition? So to get rid of addition, good. So to get rid of addition, you have to subtract.
Okay.
Okay. Now we have negative 5x squared. Okay. Do you know negative 30 minus 8?
Let me take out my calculator. You said negative 30 minus 8?
Uh-huh.
Okay. Negative 30 minus 8. 38? Negative 38?
Mm-hmm.
Oh, wow. I really need my calculator for that. Okay.
You're fine. Okay. So this is going to end up being an ugly number. Usually the rate of change, hold on, let me just make sure that's not what they want. Usually the rate of change is the slope. Divided by 3. I haven't seen that. Okay, so let's keep going. Because this is going to be an ugly number, so I'm curious. All right, so this says -5 times x squared. What's the opposite of multiplication?
Subtraction. No, division.
Good. Okay, so now do divided by -5.
Okay. Divided by -5. 6.
38 divided by 5. Not 30, 38.
Oh, right. Sorry. -38 divided by -5. 7.6.
Good. So we have a positive 7.6. And now how do I find what x is?
You would subtract?
Not subtract. So x squared equals 7.6. What's the opposite of squaring a number?
I don't know.
So finding the square root. So like if you had 5 squared is 25, you would do the square root of 25. That's like the opposite to get back to 5. So on your calculator, do that square root.
So square root of 7.6?
Yes.
Okay. It'll be 2.7.
Okay. So that, let me just see something. Average rate of change. I think I see what it was. Okay. Just kidding. So originally I thought they wanted you to solve and make that x equal -30. But it looks like when the x changes from 1 to 1.5, you got -2.7, right?
Mm-hmm.
So when x is -2.7, this is 30. Did they say put it to the nearest, like the tens, round it?
No.
So it shouldn't be coming out like that. Let me just, give me 1 second. I just want to see this real quick. Okay.
Because some of the the choices are like x equals -4 to x equals 4. And another one is like x equals -2 to x equals 4. And the other one is x equals 0 to x equals 2. And the last one is x equals 2 to x equals 4.
Minus f of a. Oh, I see. I think they just wanted you to plug it in to see if you get the same thing. Okay, so I didn't know they gave you answer choices. That's a lot easier. So give me the numbers they gave you.
The what?
The first answer choice.
The x equals -4 to x equals 4.
Okay, so let's try that. So this is B. B is 4. A is -4. Okay. So this is x of 1, x2. Plug that in here. So let's plug in -4 here. Okay, so -4 squared. So it's -5 times -4 squared plus 8. What's -4 squared?
Ow. -4. So -4, -4. -4.
So -4 times -4.
Okay. 16.
Good. And 16 times -5.
16 times -5. -80.
Good. And -80 plus 8.
88. -88.
Almost. So do 80 minus
Oh, -72.
8. Okay. So we have -72 here. Now, instead of -4, let's put in a +4. We still get 16. We still get -80. We're going to get a, what did I put? Yeah. We're still going to get a -72 here. So is that going to give us something that equals,
No.
so let's see, -20. Okay, and then -4 minus. So this is the same thing as A and B, right? So we get 4 minus -4, and we're going to get a 0 on top. That doesn't work. So let's keep going. So basically, all you're doing is plugging the answer choices in to see if it equals -30.
Okay.
That's basically what you're doing, okay? So what's the next one? The next answer.
X equals -2 to X equals 4.
Okay. So this is your A, this is your B. So for f of B, you're plugging in 4. So let's do that. We already did 4, didn't we? Yes. So we know that f of B is -7.
Hey, chill.
Okay. Okay, so you still there?
Yeah.
Okay, so -2 squared.
So -2 squared would be 2.
-2 times -2.
4.
Good. And then 4 times -5.
Going back. -20.
Plus 8.
12 negative plus 8 plus 8. So 12. -12.
Good. Yes, -12. Okay, so now let's plug it in. -72 minus -12. Okay, this double negative becomes a positive. This double negative becomes a positive. So it's just 4 plus 2 on the bottom, which is
6.
good. And then on the top, we have -72 plus 12.
Okay. So -72 plus 12. That's -60.
Good. And -60 divided by 6?
It's -10.
Good. Okay. Is that -30 yet?
Nope.
Nope. Okay. So what I want you to do right now is do the last two and see if you find one where it gives you, use this formula. So the first one they give you is A, whatever they give you. So when it was like X is -4 to 4, the first one is A, and that last one is B. And then when you plug it in, then that's F of A. And when you plug it in, that's F of B. Okay. So that first number is going to be A, that X value that they give you. And then the last one is B. Plug it into this equation. Okay. Is this calculus? Are you doing calculus? Wait, where'd you go? Oh, no. I just realized you were removed. Say it again.
I'm doing algebra.
Oh, algebra. Okay. I was like, girl, I haven't seen this in a long time.
Yeah.
Okay, but yes, so this is, so go back to the original formula and then do that, okay?
Okay. The crazy
All right,
thing
I'm
is, my
gonna check on
teacher
you.
didn't even teach us this.
They didn't teach you this?
No.
Oh my gosh, girl, you need these formulas. Wait, so this is part of IXL, so I'm assuming they
She didn't even assign a lesson. She just assigned the checkpoint. And
no.
I didn't even.
I mean, this is well, first of all, you must be pretty far ahead.
I'm a freshman.
No, I know, but on like the IXL level,
yeah,
you must be pretty far ahead on the IXL level for them to be giving you like this stuff. I'm like, girl, this ain't algebra no more. You doing a lot more than just algebra.
Oh Jesus.
This is girl. I know. I was looking up. I was like, they doing a lot of talk about calculus here. Okay. They give you a lot of upper level math stuff. So that's why. So I don't want you to get discouraged because you do know a lot. This is like, it's not just algebra. Let me just tell you that. This is more like definitely algebra 2 into the pre-cal calculus range. Okay. So that's why you're finding it difficulty, but you're understanding what you're doing. So plug those two in and tell me which ones work. Okay. All right. Let me give you some help. We're back to guess number 1. Okay. So tell me where you got stuck. Were you able to get the area of the square?
No.
Okay. That's okay. Okay, so this bottom part, do you remember that that's a square?
Yeah.
Okay. Now, how do we find the area of a square?
You add the 4 sides.
That's perimeter. So what have we been doing? Square and rectangle are pretty much the same. So what do we do with these 2 sides?
We
not add.
Multiply them?
Yep. Okay, so we just do 16 times 16 for the area. Okay, so the area of that bottom is going to be 16 times 16. And tell me what you got. Plug that into the calculator.
136.
Say it again.
136.
Not 136. It should be 256. So 16 times 16. Did you put that in 16 times 16? Make sure you get 256, okay? Now, all of the triangles are equal. So you only need to find the area of one triangle and then multiply it by 4 since they're all equal, okay? You still with me?
Can you hear me?
Yeah, I can hear you. Okay, so now what's the height? Let's choose a different.
17.
Yep. Okay, and we know that the height has to make a right angle. So look for that square. It was there. And so my height is 17. My base is what?
16.
Yep. So, oops, sorry. Height is 17. Base is 16. So we're going to do base times height. So do 16 times 17. And because it's a triangle, what's the last thing we're going to do?
Divide them.
Good. So 16 times 17, and we're going to divide that answer by what?
Half.
Yep. Excellent. Okay, tell me what you got. Oh, I think I know what you got. I think you were doing a triangle and you gave me that area.
272.
And then divided by 2. Tell me what you got. So do 272 divided by 2. What do you get?
136.
Yes. Okay. So remember you had that for the first one. Maybe that's what you got for the triangle, that 136. Okay. So if one of the triangles is 136, the other three must be what?
136.
Yep. So instead of writing 136 4 times, you can just times that by 4. And tell me what you get. 136 times 4.
$540.
Good. 544. And then what are we going to do with it?
Divide it.
So that's the area of all the triangles. So we have the area of all the triangles, all 4. We have the area of the square, surface area. What am I going to do now?
Divide it.
What's that final step of surface area, not dividing?
Add them up.
There you go. Add them together. So take that 256 and add it to 544 and tell me what you get. Oops.
800.
800. Yeah. You see it? And then inches what? What did I tell you to remember?
Squared.
There you go. Awesome. Okay, so 800 inches squared. Okay, so tell me what was confusing you about this one, because that'll help me.
It was just getting the numbers, like calculating all of it.
Okay, so do you see that once we have one triangle, then that's the triangle for all 4 that's the area for all the triangles?
Yeah.
Okay, so really you only need to find 2 areas with a pyramid. That bottom, which in this case was a square, and then one triangle and multiply by 4 since there's 4 sides. And then you add it all together. Okay, let me give you another pyramid to make sure you really got it. We haven't done triangle pyramids, but let's stop here because I feel like you did really, really, really well with these pyramids today. So I'm going to move this over here. And let me give you this one. Okay. So it's a square on the bottom. You need to find the area of the square, area of the triangle. And because it's a square, that means all the sides are equal on the bottom right here. So this, and this. All of these sides are 5. Okay. So I want you to find the surface area of this square pyramid. Okay, and let me just check. We are almost coming to a close, guys. I can't believe time went by so fast. Okay, so how did you do with, did you find the answer? Let me just move it over.
No.
Okay, what was C?
I picked a different answer. It was C. I picked D. I don't remember what the answer was. I'm on a different question now, and I'm trying to work it out.
Okay.
Okay, so the question is f of x equals negative 5x squared plus 4x.
Mm-hmm.
And so I've gotten as far as, because the first one is x equals negative 2 plus x equals negative 1. So I did the negative 2, which is 4, and then negative 5 and 4 is 20 plus 4. That would be 16, negative 16.
Wait. I thought you said plus 4x.
What?
The original f of x,
Yeah.
it was 4x right here?
Yeah.
Okay. Because you said 20, right?
Yeah.
And then you said
4.
plus.
Oh, so I should have put x next to the 4.
No. You should have multiplied that 4 and negative 2.
Oh, okay. That 4 and negative 2. So wait. So
Because you said x is negative 2, right? So you have to plug in negative 2 here and also here.
Okay. So oh wait. Okay. I think I get what you're talking about. Okay. Hold on, let me write this. Let me write it right. Let me write it down again.
Mm-hmm.
Negative 5x2 plus 4x. Bring that down. Would that be negative apostrophe x2 plus 4x. Okay, so the x I need to. Oh, okay. So I'm gonna put it. So can I put a square over the 2 so I can remember that it's 2? Wait. So why is it negative 2 if the
Because
original?
x was negative 2.
Okay.
So anytime you see x, you have to plug in negative 2.
Okay.
Okay. So 4 times negative 2 is what?
4 times negative 2 would be negative 8.
Good. And then 20 plus negative 8.
Okay. Oh, okay. So this makes more sense now.
Mhm.
So 20. Wait, I thought it was negative 20 though. Because
You're right. Just
Yeah.
kidding. Good job. Good eye.
plus negative 8 would be negative 13.
Not negative 13. So it's the same sign. So you just add.
Oh, okay. So negative 28.
Yeah.
Okay.
Okay. Let me see. Okay, good. Okay, so we have negative 28. And then plug in your x.
Okay, so do it all over again. So that'd be negative 1. Negative 1. That's negative 1. So negative 1 plus negative 1. Okay.
So negative 1 squared.
Negative 1 squared is negative 1.
No.
No,
Negative 1.
negative 2?
A negative times a negative.
It's a positive.
Yeah, so positive 1.
Positive 1.
And then 1 times negative 5.
1 times negative 5 would be negative 4.
You're multiplying.
Oh, multiplying? So
Anything times 1 is itself, right? So
yes.
negative 5 times 1 is
Negative 5
good. And 4 times negative 1
is 4.
Positive times a negative
Becomes a negative, so negative 4? No,
Yep.
no.
Yeah.
Yes? Okay.
You got it.
Okay.
Okay, and now negative 5 plus negative 4
Is negative 1. Wait,
Same.
no, that's the same sign, so it would be
Uh-huh.
negative 8.
Almost. 5 plus 4.
9.
There you go. I know they got you going. Oh my goodness. Okay, so f of b is 9. F of a is negative 28. So now let's subtract the 2. So negative 9 minus negative 28 and negative 1 minus 2. So this is really negative 9 plus 28.
Negative 9 plus 28.
Mm-hmm.
Negative 9 plus 28 is Negative 9 plus 28 is. Wait. Negative 9 plus 28 is 19.
Mm-hmm.
That's not what I'm looking for.
And -1 minus 2 is going to be a -3. What number did they want you to get?
26.
26. So we know this is not going to come out as 26, right?
Nope.
Because 19 divided by anything is not it. So
No.
you're doing the same thing. So your biggest thing is those integer rules.
Right.
Okay. Because you understand that you're supposed to be plugging in these numbers. It's the negatives and the positives that are tripping you up.
Okay.
Okay. So I would say on this question, I would use are you allowed to use calculator with your teachers? Okay. So I would use calculators on this just to help you go through each question a little bit faster.
Okay.
And then you should be able to get to the answer. But just be careful when you're putting it in a calculator and you have a negative number, just make sure you square that negative first and then multiply by 5. Then do this step. So write that answer somewhere down and then do 4 times that negative number and then add it together. So with negatives, it's just a little bit tricky. Just making sure you're putting it in right.
So for squaring, I would put the -5. I would put -5, and then I would put like the -2. Like,
so you could do this. So depending on what kind of calculator you have, what's the next answer choice? That first number.
x equals 0 plus.
Oh, that's easy. But let's say it was -1, right?
Okay. Oh yeah,
Okay.
there's one for negative. No, positive one. Do positive one.
Okay. So, well, I was trying to show you with a negative number.
Oh, okay, go ahead.
So with a negative number, you would put -5, and then in your calculator, put the parenthesis.
Right.
Put -1. There's usually a square button, like on mine.
Okay.
There's a x squared.
Right.
So put -1 squared and then close parentheses, like that one. So you have the 2 parentheses. So it'll look like what it looks like on my screen.
Okay.
Okay. And then you would do +4 parentheses -1. And that should give you the right answer.
Okay.
If you do it that way. But if you need to do it one at a time, I would say start here, do -1 squared, then multiply it. But are all the rest positives? That first number?
Yes.
Oh, then that's great. Easy peasy. Okay, but you still have to work with that -5. So just be careful when you get down to like adding them together and stuff. And then especially that ending.
Right.
Of subtracting it. I want you to stay right here. I'm going to close the show, but you'll still be in StreamYard, so I can just give you a little bit more assistance. Okay.
Okay.
Okay. Okay. So how are we doing?
I have the answer.
Okay. What'd you get?
50 centimeters squared.
Okay. Let's see. So your square. What did you get for the square? The area.
5.
For the whole area of the square?
20.
Okay, what did you do to get 20?
Multiply 5.
5 by what?
5.
Good.
I
Okay.
mean, yeah, not 25.
There. Okay, good. And then what about the triangle? What did you get for the triangle? It looks good. I think what you have is correct. So what's your base of your triangle?
5.
Okay. And what's the height?
5.
Good. And then what did you do with it? 5 times 5. And then what did you do?
I divided it
By
half.
good. Okay. And what'd you get?
Actually, no, I just I kept all of them the same and then just divided the whole number.
Okay, so tell me what that means.
I did all the 5 times 5 equals 25. And then at the final number, I divided it.
Okay, so 25, and then what did you do? What was the final number?
100.
Oh, okay. So you multiplied it by 4 first and then divided it?
Yeah.
Let's see if that'll give you the same answer. You took 100 and divided by 2?
Yeah.
Okay. Yep, that works. And you got 50, right? Okay. So your final answer shouldn't have been 50. So the good thing is that you did the triangles correctly, right? Now I need you to add in this square. So remember, just don't leave out that square because you had the 50, which means you had the area of all the triangles, which was great. Now we got to remember this square on the bottom too. Okay, so what's your final answer?
50.
What am I going to do?
25.
What am I doing with the 25 and 50?
Adding them.
Yep. Okay, so 25 plus 50, what do you get?
75.
Good. And what's my units?
Centimeters.
Centimeters.
Square.
There you go. Awesome. Okay. So you were so close. You were like right there, right? You had the 50. That means you got all the triangles. What did we leave out?
The 25.
Yes, the square. Okay. So what you want to do is just double check. And what I did, remember I did at the very beginning when we were doing the prisms, I organized my paper so that you could see, okay, I labeled all my sides, right? I had bottom, top. When we did the prism, I had like bottom, top, right side, left side, right? So for the pyramid, you can just do square and 4 triangles. That way, you're finding the area of each and you're keeping track of everything so that at the end, you won't forget to add it in there, okay? But you had the hardest part, which is really good. And you knew to divide it by 2. You got the right answer. I'm really proud of you. So surface area, once again, remind me, for surface area, what do we do?
You find the area of each side and add them all together.
Excellent. So how are you feeling about surface area? You feeling a little bit more confident?
Yeah.
Don't tell me yes if it's not a yes.
Yes.
Huh?
Yes.
Okay, good. Okay, so sorry we didn't have time for volume, but I think if you get this surface area down, you'll feel really good about volume. Volume is a lot easier. Surface area is the hardest part, and you did excellent with rectangular prism, triangular prism, and then the square pyramid. Okay, so we didn't get to cylinder. However, you did great. I'm very proud of you. Okay, so I hope you're feeling good about it. And do you have a list of the formulas in your notes?
Yeah.
Are you able to use that, like when you do like work and like tests and stuff? Do they give you the list of formulas, or do they want you to memorize it?
They're in the book.
Okay, so you can use it.
Yeah.
Okay, good. Okay, so I would just say now that you understand like the concept of surface area, I think it's going to be a lot easier for you to do that. And then volume is a whole world in of itself. We don't have time, but I'll just say it's a lot easier. The formulas are a lot smaller with volume. Okay. All right. So I want you to have a great night. Thank you so much for joining me on the show. Guys, this has been an incredible night. Oh my gosh, we went the full 2 hours and beyond tonight. I love that we were able to help guest 1 and guest 2. They are doing some very intricate math, upper level math, which is great. So if you ever need help with more math, I want you to subscribe to the channel, like it, love it, do all the things, share it, let somebody know who might be struggling with math. Every Wednesday I'm here. We might do a little bit more over the summer. But yes, definitely every Wednesday I'm here for more math homework help. School is coming to a close very soon. So let's help you ace those finals and all that good stuff. So until next time, bye guys.